I am Dr. Seema Words and we are going to talk about work, energy and power. We will learn the following concepts: work and energy, work done by a constant force, various types of energy like mechanical, thermal, light, sound, electrical, chemical and nuclear energy with examples, potential energy and kinetic energy. We will also discuss law of conservation of energy and power. Force, motion, work, power and energy are interrelated terms. Physical work is said to be done when force is applied on a body and the body moves through some distance in the direction of force. Physical work is very different from the term work we use in our day-to-day conversation. For example, thinking, reading, etc. do not signify physical work. A car moving with constant velocity does no physical work because there is no acceleration. A person pushing a wall does not do any work because wall does not move. A person having a heavy load on head and moving on a road does not do any work against gravity, as there is no displacement in the direction of gravitational force. There is a relation between work, force and displacement. Quantitatively, W is equal to force multiplied by displacement in the direction of force. Consider a block placed on a horizontal surface and a force F is applied obliquely which moves the block from P to Q. Now, PR is a projection of PQ in the direction of force. Therefore, W is equal to F dot PQ cos theta. What is the interpretation of this relation? Well, W is equal to 0 when F is equal to 0 or PQ equal to 0, or the third condition, that is theta is equal to 90 degree. When theta is equal to 90 degree, that is when force and displacement they are at right angles, work done is 0, even though the force is applied and the body moves. For example, a body moving on a circle with constant speed does no work. When theta is equal to 0 degree, maximum work is done and W is equal to F dot PQ. There is a unit of work, but before that we should know that work is a scalar quantity. It has only magnitude but not direction. The unit SI unit of work is Newton meter. 1 Newton meter is also called as joule. Let us define joule. 1 joule is defined as the work done by a body which moves through 1 meter under a force of 1 Newton in the direction of force. Well, we can now define energy. Energy is defined as the capacity of doing work. Energy possessed by a body is equal to total work done. Then what is the SI unit of energy? Well, SI unit of energy is the same as that of a work, that is joule. There is an equivalence between work and energy. Joule found out that every unit of work can be converted into an equivalent amount of energy. Joule's work energy relation gives W is equal to J multiplied by H, where J is called Joule constant and it is 4.18 Joule per calorie of heat. There is a conversion of 100% of heat into work is not possible because some energy is always wasted in the process of conversion from heat to work. Now, there are different forms of energy available to us, that is mechanical, thermal, light energy, electrical energy, magnetic energy, sound energy and nuclear energy. Discuss about mechanical energy. Mechanical energy of a body is its capacity of doing work by virtue of its position or by virtue of its motion. Mechanical energy may be of two types: potential energy, the energy possessed by the body by virtue of its position or its orientation. Second, kinetic energy, the energy possessed by the body by virtue of its motion. There is this potential energy. This happens when a body raised to a certain height above the ground has a capacity of doing work by virtue of its position, and it is called as gravitational potential energy. The gravitational potential energy increases with weight of the body, height of the body from the ground, and therefore it can be expressed as W dot H, which is equal to mgh. Let us discuss kinetic energy. A moving body has a capacity of doing work which is called as kinetic energy. When a body moving, it comes down from a height, its potential energy decreases and kinetic energy increases. The kinetic energy of a moving body depends on mass, velocity, and it is found out that the kinetic energy from the moving body is equal to half mv square. There is this thermal energy. This is a form of energy which flows out into our body to give us sensation of warmth, and when it moves out of our body, it gives us a sensation of coldness. The direction of heat flow depends on a quantity called temperature. Heat always flows from higher temperature to a lower temperature. Heat is measured in calories or in joule with the help of a device called calorimeter. Temperature is measured in Kelvin or in degree Celsius with the help of a thermometer. We have very interesting form of energy, that is light energy. Light energy is the form of energy and we are able to see things with the help of light. We receive light energy mainly from sun. Light is an electromagnetic wave with the wavelength in the range 4000 Armstrong to 7500 Armstrong. It is this energy which through photosynthesis in plants helps sustain life on this planet by providing food to all living beings. The study of light helps us devise instruments like microscope, telescope, which have taken us to microorganism on one side and the extremely large universe on the other. We have electrical energy. Electrical energy is energy associated with charged particle. Negatively charged electron move through conductor and give rise to electric current. Electric current has three main effects: heating effect, magnetic effect, chemical effect. We use heating effect of electric current in devices like electric bulb, electric heater, electric iron and geyser, etc. Magnetic effect of current is used in electric fans, electric motors, etc. Chemical effects of electric current is used for the purpose of electroplating, electrolytic refining and so on. We have a very interesting aspect of magnetic energy. Magnetic energy have many peculiar properties. They can attract small pieces of iron and stay in north-south direction when suspended freely. The energy associated with magnets is called as magnetic energy. Magnetic energy has provided us magnetic compasses to locate direction for navigation and devices like magnetic bell, magnetic crane, etc. The realization that magnetism and electricity depend on each other has led to the deeper understanding of matter, energy and many more modern achievements like radio communication. We have sound energy as well. The form of energy that enables us to hear is called as sound. Sound is a type of longitudinal waves which is originating from a vibrating body, travels through a material medium and stimulates the diaphragm of a receiver. Sound which creates a jarring effect on our ear is called as noise, and the sound which has a pleasing effect is called as music. We have developed a number of musical instruments for our entertainment. Stringed instruments like sitar, guitar, jasraj, etc. Percussion instruments like dholak, tabla, drum, and organ pipes like flute, clarinet, trumpet, etc. There is a nuclear energy as well. Nuclear energy is a non-conventional form of energy which is released in nuclear reactions by conversion of mass into energy. There are two types of large-scale nuclear reactions which are used to produce nuclear energy: fission and fusion. Fission reaction can be controlled and used to harness nuclear energy for peaceful applications by converting it into electricity in nuclear power plants. Fusion reaction is the source of tremendous energy in stars. Uncontrolled fission and fusion reaction give rise to atom bomb and hydrogen bomb respectively. There are energy transformation and conversions as well. That is, various forms of energy which we have discussed earlier can be converted from one form to another and used for useful work. During such transformation, energy is neither created nor destroyed. The amount of one form of energy that disappears is transferred exactly in the same amount to other forms of energy. This principle of constancy of energy is the universe is called as law of conservation of energy. So, the law of conservation of energy states that energy can neither be created nor be destroyed. It can only change its forms. The transformation of other forms of energy into electricity can be seen when we have examples like microphone which converts sound energy into electrical energy, electrical cells which convert chemical energy again into electrical energy, thermocouples they convert heat energy again into electrical energy, and generators which convert mechanical energy into electrical energy. Since now we know work, energy, then we can always define power. Power is a physical quantity which tells us how fast the work is done. It is defined as a rate of doing work. That is, amount of work done in unit time is defined as power is equal to work done divided by time. SI unit of power is joule per second and it is also called as watt. 1 watt is the power spent when 1 joule work is done in 1 second. Another unit of power in use is horsepower. 1 horsepower is equal to 746 watt. So, what we have learned so far? We have learned that work done depends on the direction of force, work and energy are equivalent, there are different forms of energy available and we can convert one form of energy to another. SI unit of work and energy is joules and rate of doing work is called as power. And in the last but not the least, SI unit of power is watt. Thank you.